Hello, welcome to my video about my experience of using the app Stick and Split with some Year 6 children to gain fluency with multiplication and division facts. This is part of my assignment for the Masters module, Fostering Mathematical Understanding in the Primary Classroom at the University of Derby. I chose this app because I wanted to look further at fluency and particularly at the process of repeated practice. It's called Stick and Split because every level is concerned with making target numbers by multiplying factors, that's sticking like numbers together, and often we'll need to create the factors by dividing bigger numbers into equal parts. This is called splitting. Let me show you. It's designed for children from age 5 and up who can pick it up without any teaching. So in the very first level, we need to make 4s by sticking 1s together. It quickly moves on in the second level to making 4s from 1s but also from 2s, and users can learn by experimenting and looking at the relative sizes to see how many 2s they need to stick together to make 4. From that it moves on to making 6s out of 2s, out of 3s, out of 2s and 3s, and then in level 6 we meet split. We realise that we can't make 6s from 4s. We've learnt that we can make 6s from 2s and 3s, so we need to make some 2s or 3s. If we select 4 and we press split, we can see that we can split that into 2 equal parts. And these are 2s that I can combine with the other 2 and make a 6. So I need to split up some more 4s, choose 3 2s and stick them together. There are 300 levels requiring you to make bigger and bigger numbers up to 200. Making the factors can become tricky, as sometimes you need to stick the existing numbers together and split them in a different way. Let's take a quick look at level 154. If we'd completed the levels just before this, we would have had experience of making 45s from 5s and from 9s. Here we need to work out how to make those 5s and those 9s. For example, I might stick some 3s together. 1, 2, 3, stick those together to make a 9. Now I could split a 6 into 3s that I can then stick together to make some 9s. I could stick some 7s together to make 35, and then I could split that into 5s that I could use with some other 5s to make 45, and so on. Some levels have a diamond challenge, such as complete the task in a maximum number of moves, or an instruction to find different ways to make the target number. So why is fluency in multiplication and division facts important? Apart from the requirements in the national curriculum and the national times tables test at the end of year 4, the real reason we want students to know factors and multiples is because that frees up working memory. If I know a number fact, I can retrieve it easily from memory as a single entity rather than juggling items while I work it out. The chances are that I want to use that fact to solve a problem, and it's good if I can save my working memory for focusing on the problem. Here, this problem is much easier if I know the facts 8 times 3 and 2 times 10. I can instantly turn it into this. These facts are also useful with fractions, equivalents, simplifying, finding common denominators, etc. It's much easier if I look at 4/36. I know straight away that 36 divided by 4 is 9, so it's a 9th. Other uses are area, ratio and proportion, scaling recipes up or down, working out how many packets of wallpaper paste or how many fence panels I need, and so on. In secondary school, students will need these facts for algebra and for factorising quadratic equations. Using Stick and Split has changed my thinking in 3 key areas: repeated intelligent practice, the structure or ordering of the facts to be learnt, and motivation. There's some overlap between these, but I'll address each separately. Intelligent practice. Craig Barton describes intelligent practice as tasks which can help students develop procedural fluency whilst also allowing them to make the connections and cognitive leaps necessary to develop conceptual understanding. Dan Willingham says, memory is the residue of thought. So we want students really thinking about multiplication and divisions. We need them to practice hundreds of multiplications and divisions, but if we can get them to do this in an intelligent way, they will also develop conceptual understanding and not just learn a whole load of disjointed facts. David Tim, the designer of the Stick and Split app, said, "Traditional times table learning focuses on memory techniques rather than getting to know numbers. The design of this app really does provide intelligent practice. It both helps the students give lots of thought, pay lots of attention to individual multiplication and divisions, but it also guides them to pay attention to other relationships with the numbers and the operations." Mike Askew talks about direct and indirect learning objectives. A direct learning objective might be to learn that 24 divided by 8 is 3. But a well-developed task could have an indirect learning objective of helping students notice other relationships with the numbers. One example in this app is that dividing by a larger divisor gives a smaller quotient. Students need to focus on each multiplication or division action that they make. In selecting numbers to split or stick, they're conjecturing about the outcome and then seeing what this is. This keeps their attention on that fact, which is good if we remember that memory is the residue of thought. Let me show you. In level 90, I have 24s. I know I want to make 3s to make the 27. I've got a good choice of ways that I can split the 24. I might conjecture that if I split it into 6 parts, it'll make the 3s that I want. So I do that. And a real strength here is that although I've made a mistake, I don't just see a big cross, which might make me more focused on my failure, but I see what it actually gives. I've seen students say, "Oh, I thought that was going to make," and they pay more attention to it because it's not what they expected. I'm surprised, and I look to see, well, how is it wrong? In this case, 4's too big. I can easily stick it back together again and see if I can alter my splitting to get a smaller number. The diagrams help me see that by splitting it into 8, I would get a smaller number. So I tentatively predict 8, and that's right. I then repeat splitting 24 by 8 lots of times, which reinforces that 24 divided by 8 equals 3. So, at the end of that action, I've given repeated attention to 24 divided by 8 equals 3 in a way which is much more constructive and less boring than just answering the same question 5 times on paper. And I may have given attention to the fact that if my division answer is too big, I need to split it into more parts. If I didn't make that mistake here, I won't have had my attention drawn to it here. I might have made a different mistake and learnt something different. But the chances are very high I will meet that concept and others lots of times during the whole game. Structuring the learning. I've called this area Structuring the Learning because using Stick and Split has really challenged my thinking about the order and ways that multiplication and division facts could be most effectively taught. Some of the organisation of Stick and Split is quite different from how I have previously organised learning of these facts and should offer secondary indirect learning objectives. Previously, I've introduced times tables by starting with 10, 2 and 5, then working up from 3, 1 times table at a time. Seems sensible to introduce the 8 times after the 4 times because 8 times is double 4 times, but the Stick and Split app approaches this in a completely different way. Instead of looking at whole times tables one at a time, it focuses on one multiple at a time and all the different factors which can be combined to make that. So it starts with making 4 from 1s and 2s, then 6 from 2s and 3s. By the time you reach 12, students are learning that 12 can be made by combining 2s or 6s or 3s or 4s. Gray and Tall defined the term procept to explain the fact that a symbol such as 3 plus 2 can be thought of as both a symbol and a process with an answer. They say an elementary procept is the amalgam of 3 components: a process, which produces a mathematical object, and a symbol, which is used to represent either process or object. An example is 3 plus 2. A procept consists of a collection of elementary procepts which have the same object, that's the same answer. An example of an elementary process would be 3 times 4, which is a symbol representing a process which creates an object 12. Knowing this elementary precept would mean that a student understands the relationship between those three numbers as a single unit of information in memory. Then we have procepts, which are bigger than elementary procepts. A precept is made up of 2 or more elementary procepts, such as a student knowing that 3 times 4 equals 12, and that's the same total as 2 times 6, and those facts are linked. Here we have a number of facts linked together. A real strength of the Stick and Split app is that it encourages this linked learning with these kind of connections, whereas treating times tables individually leads to some students knowing these facts in isolation and not linked together in a schema. Larson et al. Report that some students do not automatically link commutative facts like 2 times 6 equals 12 and 6 times 2 equals 12, and they say that multiplicative commutativity needs to be taught explicitly. The way Stick and Split requires students to make each number in different ways within the same level should help students to make these connections and develop number sense. There is often a view that being able to answer times tables questions quickly is a sign of being a good mathematician, but having number sense is much more important than that. Here's a quote from dyscalculia expert Judy Hornigold. Tall and Gray say perceptual thinking is characterised by the ability to compress stages in symbol manipulation to the point where symbols are viewed as objects which can be decomposed and recomposed in flexible ways. They explain there is a perceptual divide which separates those who can do this and those who rely on procedural thinking. In my classroom, that divide is between the children who, when faced with 16 times 25, know instantly that there are 4 25s in 100, and 4 times 4 is 16, so it will be 400. And those who will need to perform a long multiplication or laboriously write down 16 multiples of 25. As you can see, it takes much longer and is prone to many more errors. And some of them will need to write their 5 and 2 times tables down at the side while they do this. Another difference in approach is that it starts with small numbers and gradually works up. Writers such as Griffiths, Back and Gifford exalt the ways and importance of helping infant children understand number sense, and they say this includes counting, composition and also comparing, and they advocate starting with the smallest numbers and then gradually getting bigger. Griffin and Case found the importance for children in linking numbers to quantities. My traditional method of teaching times tables had children learning about 27 before discovering that 4 times 4 is 16, and that's probably during a time when they could be getting really good at the number sense of teens numbers, but they don't really have such an understanding of numbers in their 20s. Moving on to division, teaching children's times tables in the traditional way promotes multiplication over division and doesn't do justice to the inverse relationship between the two. I used to work hard to ensure that the children knew the multiplication facts and mostly expected that their knowledge of division facts would just follow. This extract from the Year 2 National Curriculum shows that division is just mentioned at the end of the paragraph as if it's an afterthought, something to be tackled after multiplication. I now understand that often children as novices need help to make many mathematical links which we as adult experts just take for granted, and we don't realise that they don't see them. In a recent Year 6 assessment, many children couldn't choose the related multiplication fact to check this division calculation. Stick and Split teaches division alongside multiplication, and the fact that I can stick 6 2's together to get 12 and then immediately split them back up by splitting into 6 parts which are 2's each, shows explicitly this inverse relationship between multiplication and division. Another feature of Stick and Split is that it aims to avoid children just using repeated addition. A child who needs to count up through the times table on their fingers to reach 4 times 3 doesn't know the elementary precept of that multiplication fact and will have even greater problems with something like 14 divided by 3. Aside from that, it also promotes the bar model representation of multiplication, which is very helpful. Motivation. Another quote from Dan Willingham. It's virtually impossible to become proficient at a mental task without extended practice. The learning of times tables requires lots of extended practice, and a significant problem is how to keep students motivated. In the past, I believed that children were motivated by challenge, and the easiest way to provide that was to add a timed element. However, recently I came across research into maths anxiety, which started to worry me. Joe Bowler states that timed testing can be a trigger for some students to develop maths anxiety. Steve Chin says that having to work out maths answers quickly was ranked highly by all groups on his maths anxiety questionnaire. This gave me a bit of a dilemma. Some children seemed to be enjoying and were really motivated by these speed games, but it could be a trigger for others to start suffering anxiety. For the sake of those students, I should stop using those sort of activities, but what would motivate lots of the other students? An alternative method would be to use video games. Stick and Split is essentially a video game. Paul Howard-Jones, neuroscience professor at Bristol University, says games are very good teachers because they induce anticipation, leading to midbrain dopamine, which is very engaging and speeds up learning. Research by Jagerst et al. Say that best engagement and performance appear when a game player is challenged at levels aligned with his or her skills. And a really good feature of Stick and Split is that the students can choose which levels they would like to tackle. They can jump forward or they can repeat levels. A lot of apps I've found are locked down, and I find that the students can't access what they need without ploughing through a lot of easy stuff, and then they can then get bored. Jagerst et al. Found that this match with their skills was more effective than leaderboards, which can be motivating for some students but not for others. This is probably because it's success that leads to motivation rather than the other way around. And here's a quote from Garan Carrier et al., who found a directional association from prior achievement to subsequent intrinsic motivation. And we want to be encouraging intrinsic motivation, where students are motivated because they want to be successful at the maths, rather than extrinsic motivation, such as wanting to beat a classmate or collect lots of points, which has been proved to undermine their intrinsic drive. So an ideal app would foster intrinsic motivation and provide challenge, which is closely aligned with student skills. I found that Stick and Split fits this very well, and the students are very keen to play it. Future practice. I would definitely use this app again with children. I'd be very interested to see how it would work lower down the school, where children haven't been introduced to times tables in the traditional way first. I've been using it with Year 6 students. I'd like to look further into how well they then link the number sense that they gain with the standard notation for multiplication and division, and how well they could use it to solve problems. Children often struggle with word problems, in particular because they don't have good models of the operations. With the old system of teaching times tables, some haven't really understood what multiplication and division are. I think it would be important to teach other models of multiplication and division alongside using the app. Whilst it promotes number sense over repeatedly doing addition, it still shows the equal groups model of multiplication, which is usually linked to repeated addition. And this is one of the models we want students to understand. However, we need them to be aware of other models too, especially arrays and the area model. Research shows that students cling to early models they've learnt, and repeated addition doesn't transfer to multiplication of 2 decimals, which is better understood by the area model. Splitting demonstrates sharing rather than the grouping model of division, and students need to know both as well as the scaling down model, and once they've recognised the structure of a problem, they can use any of these methods to solve it. Overall, I, as well as my students, have learnt a lot through looking at this app. I'd like to especially thank David Tim, the creator of Sunflower Learning, for taking time to talk to me about it. and for allowing my students to use the free school app as part of his research project. I would recommend that other schools take advantage of this extremely good offer.